Hello students, welcome back. In this video, we are going to discuss a complete C program on queue operations, queue implemented using arrays. So let's start the program. So I'll start from hash include stdio.h, then hash include conio.h. Console input output operations can be done by using conio.h header file, right? And then we'll define this macro hash define for size of the queue, hash define size. Let's say the size of the queue is 10, right? And then I'll define the structure for queue. So struct queue, and then here inside the structure I have the array int data, and the size of the array is size. This size is 10, so this is an array of size 10. The last location will be 9, which is size minus 1, right? Okay, so then I have two variables here, int f and int r, right? F and r, front and rear, right? So that is the structure for queue. And then we'll declare the various functions which we are going to write here. The functions like will have initialize function void, which will initialize the queue. To this initialize function, we'll pass the address of the queue which we want to initialize, right? So we need a pointer here, struct queue star p, right? So this is just declaration. We'll write the definition later. Then we'll write the empty function void empty. Again, to this empty function so this is not void empty, by the way, this is int empty. So int empty here I should say, because it will return 1 if the queue is empty, otherwise it will return 0. So that's why it is int empty. To this empty, we'll pass the address of the queue which we want to check whether it's empty or not, right? So this empty will check and return 1 if the queue is empty and return 0 if the queue is not empty. Then similarly, we will have full function int full. So this full function also will return 0 or 1. So to this full function also will pass the address of the queue. It will return either 1 or 0. If the queue is full, it will return 1. If the queue is empty, if the queue is not full, it will return 0. Then we have enqueue and dequeue function. So the return type of enqueue will be void because it will simply insert in the queue. It will not return us anything. So void enqueue. But to this enqueue function, I need to pass two things. First is the queue in which the insertion is to be done and the element which is to be inserted. So void enqueue, two things, the address of the queue, pointer for that address, and second thing is the element which will pass. So two parameters it will receive, the address and an element to be inserted in the queue, right? So int dequeue, so this dequeue function will remove an element from the queue and it will return that element to the calling function. So to this dequeue also will pass the address of the queue, struct queue. See, this struct is all small, right? Struct is all small. S is small, T is small, R is small, right? It's a keyword in C. C is a case sensitive language and all the keywords are in small letters. Right, so that is initialize, empty, full, enqueue, and dequeue, right? And then you can also print void print. We'll print the queue at that particular point in time. So void print, and to this print also we'll pass the queue to be printed. So struct queue star p, right? So this is these are the functions which will require. Now let's write the main function. After declaring this, let's write the main function, void main, or you can write int main. So this is our void main. Inside main, the first thing is I'll create the object of this queue, right? I'll create the object of this queue. Struct queue. This capital Q is an object of this queue, right? And then I'll need some variables. I'll declare those. Int I for looping purpose I'll require, right? N I'll require, maybe I'll require X. So on and so forth. I'll declare them as and when I'll need them, right? So that's why this dash dash dash, right? Or you can directly put a semicolon here. Right? I'm hoping that I'll require only these three, but I'll declare the variables as I need them. Right? Okay. The first thing I'll do is I have just now created the queue. I'll initialize that queue by calling the initialize function. Initialize. Initialize. And to this initialize, I'll pass the address of this queue. So this initialize function will set this queue, right? So we'll set this queue. This is the queue. F and R will be set to -1, indicating that the queue is just now created and it is empty, right? Okay. And then after initialization, we will perform some enqueue operations, right? So I will ask the user, enter some numbers, enter 5 numbers, for example, and we'll enqueue those 5 numbers inside this queue, right? So I'll ask the user printf enter 5 numbers, right? These 5 numbers we want to insert in this queue, right? So I'll read the 5 numbers for I assigns to 1, I less than equal to 5, I plus plus, right? So user will enter the first number and that I'll store in, let's say, X. So scanf, user is going to enter a number that I'll read and store inside X. Let's say scanf, the number entered by the user I'm storing in X. So and X, right? Now I have got an element number in X. So this is X, let's say this 10. I have got this queue. Last location is now 9 because the size of the queue is 10. The last location should be 9. We are starting from 0. Now I have the number here, I have this queue, I want to insert this 10 inside this queue, right? So now I will call this enqueue function, but before calling this enqueue function, I'll make sure that the queue is not full. So I'll call empty function here. If not empty, to this empty I'll pass the address of the queue, right? This empty will check whether the queue is empty or not. If it is empty, it will return 1, right? 1 will be negated, it will become 0. That means when the queue is empty, will not execute this. When the queue is empty, will not execute. We should call full. I'm sorry, we are performing enqueue now. We should call full here. Just so before performing enqueue operation, we should call full, not empty. My mistake, my bad. So I'll call full. So if full, let's say not, let's not use this not concept, not because it's confusing. So I'll use directly full. If full and queue. I'm calling full and I'm checking, is the queue full? If the queue is full, this full will return 1. That means this condition will be true and the queue is full. So this time I'll say printf overflow. Overflow, right? I'll simply print overflow, right? And then maybe yeah, I'll keep on printing the same message for other elements also, or I may write exit 0 so that I can exit from this loop, right? Right? If the queue is full, I'll print overflow. Else means the queue is not full. The queue is not full. In that case, what will we do? We are doing enqueue operation. We have seen. So enqueue operation, when the queue is not full, there are two situations. The first situation is, or I mean, we'll do that in the enqueue function directly. But here, else, what will I do? I'll call this enqueue function, right? Enqueue, else, enqueue. To this enqueue, I'll pass the queue address of the queue and the element to be inserted, right? If the queue is not full, this bracket is not required actually. So if the queue is not full, I'll call enqueue function. To this enqueue, I'll pass this queue's address and this element, right? So these two things I'm passing to enqueue. So this loop will run 5 times, right? Every time we'll read an element in X and then check if the queue is full. If the queue is full, we'll print overflow. Otherwise, we'll call enqueue function, right? So this is the main till here. Let's continue in main only. We'll see mains, the entire main function. Then we'll go for the individual functions, initialize, empty, full, and all those. So now, as we have performed some enqueue operation, let's perform some dequeue operation, or only one operation will perform, let's say. So before performing dequeue operation, so here I'll change the color. Let's say orange I'll use. So if not empty, or I'll not use this not concept, right? Because this is slightly confusing. So it may confuse to the students. So that's why I'll not use this not concept. If empty, I want to perform dequeue, but before dequeue, I'm calling empty function. To this empty function, I am passing the queue. Whenever I'm saying I'm passing the queue, that means I'm passing by reference or address. This empty will return either 1 or 0. It will return 1 when the queue is empty. If 1, that means this condition is true, queue is empty, I'll say printf can't, or underflow directly, right? Underflow. Right? So before this, you could have printed a message for user that performing dequeue operation. You could have printed that message printf dequeue. Long message you could have printed performing dequeue operation, and then actual dequeue will be starting here by checking if the queue is empty, right? If queue empty, underflow, else, that means the queue is not empty. In that case, what will you do? You will simply call the queue. If the queue is not empty, we'll call the dequeue function, right? And a dequeue function will remove an element from the queue, and it will return that element to you, and you will store that element in X. X is equal to dequeue. And to this dequeue, I'll only pass the queue's address. Here, I need not pass which element to be removed or dequeue, right? So I need to only pass the queue, right? So this is dequeue, right? And then after performing dequeue, you may want to print. If you want to perform this dequeue more number of times, so you put this code in loop. For example, if you want to perform this dequeue twice, for I assigned to 1, I less than equal to 2, I plus plus, and just put this code in loop. So 2 dequeues will happen. Right? And after this dequeue operation, let's print the queue, right? By calling the print function. Print, and to this print, I'll pass the queue, right? So this print will print the queue. And then we'll say get ch, right? and then we'll stop here. This is our main function. This is our main function. Now let's see the remaining functions one by one. Right? We have already seen those, but I just want to show you the complete C program. Right? So let's see those functions one by one. So the first function is initialize, right? Initialize. Void initialize. To this initialize, we pass the address of the queue. So that address will be stored in a pointer. So queue struct queue star p, okay? And we'll simply set p arrow f equal to or assigned to p arrow r equal to -1, right? So that's it. That's the initialize function, right? So both f and r will be set to -1. Then empty and full. Int empty. To this empty, we'll pass the queue struct queue star p. Right, I'll simply check if p arrow f equal to -1. I'll say return 1, indicating that the queue is empty. Else I'll return 0, right? So p arrow f. Why p arrow f? Because we have this pointer p pointing to the queue, right? Pointer p pointing to the queue. This queue will be in main. So I'll pass the address of this queue, and the address of this queue will be stored in p. That means p is pointing here. And if I want to access f, which is inside this queue, I should say p arrow f. So p arrow f will give me access of f or value of f. And if that is -1, that means the queue is empty. I'll return 1. Else I'll return 0. Okay. Similarly, int return type is int because I'm going to return either 1 or 0, same as empty. Int full. To this full also, I'll pass the address of the queue. So I need a pointer here, star p, right? And then if p arrow r, right, when checking the queue is full, I'll see what is r. So if r is equal to last location, and what is the last location? If the size of the array is size, if this data array, what is the size of this array? Size variable. Size is 10 here. If this data array size is size, then the last location will be size -1, right? Because we are starting from 0. That means if r is equal to size -1, that is last location, we'll say that the queue is full, right? So if p arrow r equal to size -1, right? The last location will be size -1. Size here in this case is a macro whose value is 10. So this will be 10 -1, 9. If r is the last location, which is 9 in this case, then we'll say that the queue is full, and that's why we'll return 1. Else we'll return 0. That is the full function, right? Now let's see empty. Let's see enqueue and dequeue, right? So just a moment. So here is our enqueue function. So void enqueue. To this enqueue, we have passed two things. First is the queue address, struct star p. This p will hold the address of the queue, and other is int x, let's say. Then as we have seen while performing enqueue, there are two situations. What are those two situations? First is we are inserting in an empty queue. Other is we are inserting in a partially full queue. So how will we make sure that it's an empty queue? So if p arrow r equal to -1, that means the queue is empty. So when we are inserting in an empty queue, we'll set p arrow r equal to p arrow f equal to 0, right? And then we'll go to data array, p arrow data of P arrow R location inside data array. On R location we'll insert, of course this P arrow R will give us 0, right? This X, I'm sorry, this X. So this is X. X is inserted in the data array on R location, right? If the queue is empty. Else means the queue is not empty. There are some elements already present in the queue. The queue is partially full. In this case, what will we do? We will simply increment R by 1. So P arrow R equal to P arrow R plus 1, right? And then we'll go to data array, P arrow data of P arrow R equal to X, right? That's it. That's the enqueue operation, right? So two situations, we have clearly seen those in the previous videos. If you have not watched those videos, please watch those videos. That is enqueue operation. Now let's perform dequeue operation. Int dequeue. The return type is int here because we are removing an element from the queue, and then we are going to return it to the main. Int dequeue, right? So we are passing the address of the queue, so I need a pointer here. Star P. So again, we are calling this dequeue after making sure that the queue is not empty, right? So if the queue is not empty, I'll directly get an element from the data array, P arrow data of P arrow F. While performing enqueue, I'll use only F. Sorry, while performing dequeue, I'll only use F. While performing enqueue, I'll only use R. So I got this element, and now I'll check whether this was the only element in the queue. How will I check that? If P arrow F equal to P arrow R. If F and R are same, that means the element which we just now removed was the only element, and if I have removed that element, I should set F and R to -1 because I just removed the only element from the queue. So I'll set P arrow F equal to P arrow R equal to -1, right? Else means I removed, there are more than one elements. In that case, I'll simply increment F. Else P arrow F equal to P arrow F plus 1. Right? I'll simply increment F by 1 and then return X. So that is the dequeue function, right? And then now let's see the last function, which is the print function. Void print. And to this print also we have passed the queue. That's why we need a pointer here. Struct queue star P, right? So there is the address of the queue is stored in this pointer. So before printing this queue, I'll need one variable here, int I. Before printing this queue, I should make sure that the queue is not empty, because if there are no elements in the queue, how can I print that, right? So if P arrow F is not equal to -1, right? If P arrow F is not equal to -1, right? If it is -1, that means the queue is empty. When P arrow F is not equal to -1, then only I'll print the queue, no? Otherwise here I could have called empty function also, right? I could have called empty function also, but I'll directly check it here, right? Rather than saying this, I would have also said that if not empty, right, and this is empty, I'll pass the address which is there in P, right? I'll simply pass P. P is already holding the address of Q. That means when I'm passing P, I'm passing the address of Q, right? I could have done this also instead of this, right? If the queue is not empty, right, this is the situation. let's say this is 0, 1, 2 up to 9. So f is equal to, let's say, 1. Let's say we have deleted this element is not there, and r is equal to, let's say, 7, right? So there are elements present from 1 to 7. So I should start printing q from f and go till r, because r is 7. So if q is not empty, then what will I do? I'll print, rather I should start a loop from here for I assigns to p arrow f. P arrow f means 1 in this case. P arrow f I less than equal to p arrow r. That means I'm going till r, right? Why I'm using p arrow f and p arrow r? Because we have pointer pointing to this q. I have to use this pointer to access the value of f and r. I plus plus, right? Simply printf %d the element in the data array, right? P arrow data, P arrow data of I, right? P arrow data of I. So yeah, that's it. So I is taking value from 1, whatever f is, right? I will start from that location. F is 1, I'll start from location 1, right? If I is 1, P arrow data of 1 will print the value here. We'll go up, increment I becomes 2, right? And then I'll check, is it less than R? Yes, 2 is less than R. Then we'll print the element at P arrow data of I is 2. So P arrow data of 2 will print. So this loop will continue, right? Till we reach to this 7. And once we print this 7, this I becomes 8, and we'll quit this loop. So this is the simple loop to print the Q, right? And this is the complete C program for implementing Q using array. This is the very simple C program. You can make it very sophisticated, right? So I'll show you the complete program. So we started from here. We did this operation, this, and this also, right? This is the main function. We initialize the queue. We perform some enqueue here, and then we perform a dequeue operation, and then we printed the queue, right? So this initialize, empty, full, enqueue, dequeue, and finally print. So I hope you will enjoy this video, right? So we'll discuss the next topic in the next video. So stay tuned and see you there. Thank you.